Hello my dear students, how are you all? Welcome to our YouTube channel Diksha Karnataka. I am Ankit Sir bringing you our ongoing series which is 60 out of 60 in KCET Mathematics in 100 days. Today I am very excited because we are starting a new unit today bacha, which is nothing but calculus. Okay, as you know, in your PU2 portion most of the questions are coming from calculus part, right? That makes this unit very important, right? So we have taken the first chapter of the unit which is nothing but continuity and differentiability. Continuity and differentiability. Okay sir, but in the session today no, we'll not talk about the actual chapter. We will try to revise something. What is it sir? Limits. Why it is we are revising sir? Because in the chapter we will recall the concepts of limit multiple times. So it's very important to create a link, because you learned this chapter in PU1 and now if you're in PU2 you might not remember everything at once. So it's very important to recall these things. So the session will be short, okay? So only we will deal with what is a limit, why do we need it, okay, and we'll solve some questions on it on different type of functions, and also we will take some P by Qs, okay? So I hope you're excited with me to start the journey of calculus in our ongoing series, right? In the series itself it's another series of calculus, so I hope you are very excited. So let's start with the session. So get your pen and paper ready. Will not give you a lot of time because the questions will be very short. I'll take up graphs, I'll take up some concepts and quickly solve the questions and keep moving on, okay? So starting with the session. What is it? So we have taken a function here. What is the function? Let's check. The function is obviously a reciprocal function, x square minus 4 upon x minus 2. The function is defined as y equal to x square minus 4 upon x minus 2. This function is not defined at a point. What is that point? So x equals to 2. So if you take a point x equals to 2, fx or y is not defined. How come sir? Because bacha, the denominator will become equal to 0, then the function will be not defined obviously. So if then sir, can we not find the value of the function at 2? Of course not, we cannot find the value of the function at 2, but there is something called as limiting value. We cannot find the actual value of the function at 2, but we can try to reach as close to possible to that actual value. And what is that? Means if I try to reach, means I cannot take x equals to 2, because x equal to 2 is not part of domain, right? Means x, if I have to write the function's domain, what is it? It's real, all real minus 2. Means I can take any real value except for 2. So 2 is not part of the domain. Yes sir. So this is open bracket actually, not visible. Let me check. This is open actually, means at the 2 value the function is not defined. What is the value before 2? Right before 2, it is sir 4. How come it is 4? Please check here. If I take this function y equals to x square minus 4 as x minus 2 times x plus 2 and divided by x minus 2, whenever for all the value where x is not equal to 2, I can cancel these, right? Because if x is equal to 2, then both of them become 0. I cannot cancel 0 and 0, right? But whenever x is not equal to 2, I can cancel these. So what is my function going to be? X plus 2. So if you look at the values of x where x is not 2, I will get the graph of this function as a straight line, y equal to x plus 2. Please check. For the values of x after 2, on the right of 2, the graph will be a linear equation. Same way before 2, the graph will be a linear equation. Means the function is defined before and after 2 but not at 2. So what can you do about 2? So we can find a limiting value. We cannot find the value of the function, means f of a. We cannot find f of 2. This we cannot find, but we can find the value when x tries to go as close as 2. Means how close? So if I have to say how close, I can go as 1.999999. I cannot reach that point. Means how close we cannot define it, okay? That number is not defined, how close. But if there will be a number which will be very, means if I say 2 on the number line, there will be a point right before 2. Okay, so we cannot define that point, that is not defined. How close we cannot define, but there will be a point right before 2. Same way there will be a point right after 2 also. So we are trying to write the value, 2 is not there. For example, if I take any number less than 2, what will happen? This will be a negative number. If I take 1.999999 so on minus 2, then this will be a negative number, right? Same way if I go from the right hand side, it will be again a very positive number, very small positive number. The point is, we can go to that value. We can go to that value, correct? So if we do that, what we're gonna get? That will be actually, so function value is what? The function value, if you look at here, okay, if you look at here, let me erase some part which is not relevant here. So if I remove this, you already understood that at x equals to 2, the function is not defined. Okay, sir. Let's find the limit of the function. So if I try to reach the function from the left side of 2, from the left side of 2, means how we write it? 2 power minus 1, means we are trying to reach, or not power, actually representation, we are trying to reach 2 from the left hand side. Okay, so if I do that, what is my function now? The function has transformed into y equal to x plus 2. How come, sir? Because I have taken a case that x is not equal to 2. X is not equal to 2. And when I am saying that x is going to 2, does it mean x is equal to 2? No, sir, it does not mean that. It means that when x is trying to reach as close as to 2, but not actually equal to 2, what happens to the function? Check here. What happens to y? Y will be 2 plus 2, right? 1 point, let's say if I take a number 1.999 and never ending plus 2, how much is that? It'll be 4. Okay, so basically I can summarize this as if x is tending to 2, what is my value of y? Y is getting 2. Y is getting not 2, y is becoming 4. Forgive me, y is becoming 4, bacha. Same way, if I try to reach, so this is from left hand side, if I try to reach from right hand side, same way the function value will remain same, x plus 2 only. So if I try to reach this function from this side, if I try to reach, again it will be what? 2.00000 like this. It'll be what, bacha? It'll be 2.00000. Where 0? Where will it end? No, sir. Somewhere at the last, it might be 1. Okay, some other number. So if you add this to 2, how much this will become? So if I try to reach x from the right hand side, 2 plus, what will be my y value? Again 4. All right. So I hope you understood. Whether I try to approach 2 from left hand side or from right hand side, I will be able to reach the value 4. Sir. Okay, sir. All right. Now, sir, why are you writing equal to 4? Okay. Sometimes people write this also, bacha. Okay. Let me write it here. Sometimes people will write this. X tends to 2, y tends to 4. This is not correct. Okay. When x tends to 2, y is equal to 4, not tend to. Because why is that true? Because limit always gives us exact value. When x is tending to, this means that x is actually not equal to 2. But when I say limit is 4, it means y is actually equal to 4. So limit, even though I am not able to reach that x value, but limit gives us exact value. Always remember this. Always gives us exact value. It will not be a tending value. It will always give you exact value. Okay. So all right. So far, if you have to summarize, I'll summarize it later. Right now, let's move on to the next part. So far what we have to recollect, for a function where in a domain you cannot define it, a point you cannot define it, the function means f of a or f of 2 we cannot find it out, then instead of finding the actual value at the function, we find the limiting value. And how we do that? We try to approach the functions from the right hand side or left hand side and try to reach to a conclusion using the new well defined function, and in this particular case we get both the situations as 4 and 4. Both the situations are 4 and 4. So what is the reason to study limits? Functions will be there which might not be defined at every single point, but still we will be able to find the limiting value of the function at that particular point. Correct, sir. So something called as deleted neighborhood of a point A. Okay, sir. So what it means, please check. Please look at here. So if I am talking about x equals to A, a point x equals to A, then I will take a very small number delta. Very small positive number. Okay, it's a very small positive number, very small. So if I move that unit towards left and that unit towards right, okay, then this range a minus delta to a plus delta will be my deleted neighborhood. See here, a minus delta to a plus delta will be my deleted neighborhood except for a, means I have to take out a, bacha. A cannot be there. A cannot be there. Reason because at A the function is not defined. So see here, the element A, this is written like this, a minus delta to to a plus delta, removing the element a. Means everything is there, just a is not there. This is called as the deleted neighborhood of point a. Means we are trying to approach, means where we are defining this function from here to here. A minus delta to a plus delta except for value a, except for value a. So see over here, if I have to divide this, I can divide it like this also. So a minus delta to a, check here, a minus delta to a, okay, and same way a to a plus delta, a to a plus delta. The left side is called as left neighborhood of what? A, and this is called as right neighborhood of a. Obviously, right? A to a plus delta is right neighborhood, a to a plus delta is right neighborhood, and a minus delta to a is left neighborhood. What is delta? Repeat. What is delta? Delta is a very small positive number. Very small positive number. Correct, sir? Correct, sir? Okay, sir. All right. Let's see. Now, we talk about left hand and right hand limit. Okay. Same thing. If you look at this graph, means I reached two different values, right? Means when I was trying to approach the graph from positive side, from this side, what I got the value of y as 4. Correct? And in this case, when I try to approach the graph from negative side, what did I get the value of y as? 4 again. So in this case, we got the both values as 4. So I can say my left hand limit and right hand limit are same as 4. So this part is called as RHL. RHL, because we are trying to approach the value 2 from the right hand side. So right hand limit. Same way for this, we call it as LHL. LHL means left hand limit. Why left hand limit? Because we are trying to approach this 2 from left. Okay. For that reason, we call it as left hand limit and right hand limit. All right, sir. Okay. Please see the definition over here. If I am trying to approach for a function fx, okay, from the left of a, if I get L, then this L will be called as left hand side, which will be called as left hand limit. Okay. Means f when x is not equal to a, obviously this is important now, because if I am trying to find x tends to a, this simply means x is not equal to a. Okay. For right hand side, if I am doing, okay, this is my RHL, this is my RHL. Let's say I have this as m and this as L. Okay. Let's see. Now, once we learn what is left hand limit and right hand limit, next part is to know when can we say the limit exists. Okay. So what is the meaning of limit existing, sir? Because first we said what? That at x equals to a, function does not exist, right? Or you can simply write it as DNE. Does not exist, or basically not defined. What about limit? How can we say whether limit is defined or not? Sir, can we say if the function at x equals to a is not defined, then limit will always be defined? Not necessarily. Even though the function is not defined or defined, we cannot say limit is always defined. So when can we say limit is always defined? That will be considered or will be understood from existence of the limit. So this is only true, the limit is only defined. First of all, function is not defined, you understood, right? How is function not defined? If the value of f of a you cannot reach, it will be undefined value. Something we call it as so actually you'll reach a undefined value. So how can we say this? Something you call it as indeterminate form. We'll learn about this in detail right now, but for now, if you remember, I'll just write it as it's not readable, I guess, so let me write it again. Bacha, yes, forgive me please. Indeterminate form. It's somewhat readable, not very nice, but somewhat readable, right? So this is indeterminate form. Means when you reach here, then you will look for limits. Okay. Then when can we say limit will exist or not? Only if your LHL and RHL are equal. Means if you try to approach the function, let's say over here, from right hand side or left hand side, okay, and you're able to find and say that LHL, or we call it as L1 sometimes, is equal to L2. Okay, RHL is L2. When this is true, then we can say limit exists, sir. We can say limit exists, sir. When we will say when LHL and RHL are equal, means both the values are, if they are m, then I can say limit exists and they are equal to m. They are equal to m. So you look at here, f if I approach from negative side and approach from positive side, what I'm able to reach a finite value, a limit. In this case what we had that finite value as, we had that final value as 4. This finite value was 4, sir. So I was able to approach the limit. If you see here, if I write the summary over here, I said no, I'll write it here. So if I write the summary over here, please check. So for this function fx, okay, when I was trying to reach x to 2 minus, I got this limit to be, I got the limit or L1, let me write better, L1 or LHL I'll write LHL. So I got LHL to be equal to 4. When I approach this function limiting condition from positive side, I got RHL to be 4. Okay, when this is true, what are we getting? LHL equals to RHL, which is equal to 4. Then the limit of the function will be what? The limit of the function at x equals to 2 is nothing but 4. Okay, so if LHL and RHL are equal, we can say limit exists. And what is the value of the limit? Basically equal to the number, the finite number. This 4 is the finite number in this case. This 4 is the finite number in this particular case. Yes, sir. This much we understood, sir. Okay. Now I said no, something called as indeterminate form, means where we will have the conditions or situations where we have to find out the limits. Okay. That will be checked, means the need will be checked from here. If you have these forms present in the given function at a particular point, okay, always remember limits are found at a particular point, means at x equals to a, some value, if I put this value a in the function, if I put this value a in the function and I get one of these forms, then I will be able to, or I will have to solve for limits. Okay, then I will have to check for the limits. For example, in this condition you check. So a few of very standard indeterminate forms that we have are, when the question after putting, so if I have a function fx, after putting x equals to a, the function is getting to this form 0 by 0 or infinity by infinity or 0 into infinity or infinity minus infinity, 1 power infinity, 0 power 0 and infinity power 0. One of these forms, if you are able to arrive after putting x equals to a in the function, then you have to find what? You have to check for the limits. Again, how will you check for the limits? Find LHL, find RHL. If they are equal, then yes, you'll say limit exists. If not, then you'll say even function is not defined and limit also does not exist. Okay, we'll see the situations. All right. So if you have learnt about indeterminate form, let's quickly check some determinate forms also. Determinate forms as well. So one of them is, I can write it as a times infinity. If I'm multiplying a number a with infinity, okay, let's write it as k, because we have already taken a for the other value, so let's take it as k. Then this will be simply infinity. This is not indeterminate form, this is a determinate form. Okay, I can also take 0 power infinity. This will be simply 0. Okay, I can also have infinity plus infinity. This is also simply infinity. What about the other case, sir? Minus infinity is also minus infinity. Check here, this is infinity minus infinity. This is indeterminate form, but whereas if you have infinity plus infinity, it will be infinity, and minus infinity will be negative of infinity. Okay, there are a few more, but you can just, I'm trying to give you a condition where if you solve a question and then these cases are there, okay, then you cannot take it as indeterminate form. You cannot take it as indeterminate form. You cannot conclude that it is indeterminate form. That's my point is. Okay. All right, so this is clear, right? These are few standard, and they are actually, when you learn this chapter in detail, what happens is they are actually, you can transform one of the indeterminate form into other forms also. Means I can transform 0 to 0 into infinity into 0 also. All right, so I hope you understand this, you have learnt it. If not, then when we start with PU1 portions, I will teach you there, like how can we transform one of the indeterminate form to other indeterminate forms, sir. Let's move on. Okay, now the question part, my favorite part, right? Because what we learn, when we learn more, when we have problems in front of us. So that's why I like the questions the most. If I have the questions, learn the concepts. Obviously the concepts are very important, but after learning the concepts, it's very important to practice the question. So I hope at home you are all doing the same thing, right? No sir, we are just resting, watching the videos and doing nothing. Do not do that. Make sure that after learning a concept, you practice some questions on it. Otherwise, there's no point of working over it. There's no point of wasting your time on anything. So if you are watching or learning some concepts, move on and solve the questions. At least you solve the questions that I'm solving in the session. That will also be very, very helpful. Okay, if you can solve this much, then if you want to have more practice, do the reference books. Okay, solve the question from reference book, from the PYQ section. All of it you have to solve, bacha. So limits I'm teaching you. See, this is not part of your PU2 portions, but still I'm teaching you so that you will be able to recollect and connect with me when I'm teaching you continuity and differentiability. So let's start. First question, what is it saying? It says function is defined as, what is this function? I hope by now you all know. This is GIF, right? Greatest integer function of x. Okay, so this is the function defined like this, and they are asking us to find the limit of the function when x is equal to 2. Okay, so let's quickly look at the graph of this function. How will the graph look like, bacha? So if I look at the graph, so at 0 it will be 0. Please check. Okay, okay, then it will be open here. Okay, then I'll have it here as 1, again open here. Why I'm doing this, bacha? Because we need to do it for x equals to 2. I don't need a negative value. Check here, I have to find it at x equals to 2. So what I'm trying to do is trying to reach the conclusion where we can find the limits over here. So this is my value 0, 1, 2, okay, and this will be the graph at 2. What is this value? This is 1, this is 2. Now please check. Please check. I hope you can answer the question from the graph only directly. So if I try to approach 2 from right side, from this side, I'm trying to approach 2 from right side. So I'm trying to approach 2 from right side. What is the value of the function? How will the function will look like? The function will give me value as, or simply if I have to write just y, when approaching the value from 2 positive, I'm getting y equal to what, bacha? Check here, y equal to 2, correct, no? On right of 2, what is the value? 2. Okay, please check, 2. If I try to move from here, what is the value of the function? 2, sir. All the time it is 2, sir. Please check. Okay, what about I'm trying to approach the function from left hand side? So this is my RHL. I hope you know that now, by now. This is my RHL, this is my LHL. Okay, LHL. Try to approach the number 2 on x from the left hand side. So what is my value at all this time? It is 1, sir. It is what, bacha? It is 1. It is 1. So what is my value? 1, sir. Now don't say, sir, at 2 it is 2, no, sir. You are taking this point. So at 2 it is 2. I said no, when I say x tends to 2, when I say x tends to 2, it means x is not equal to 2. So I cannot add the two value. I have to take before and after. Right neighborhood and left neighborhood. So right neighborhood I am getting 2, left neighborhood I am getting 1. It means LHL is not equal to RHL, which means limit at x tends to 2 for the function fx, what happens? Write in capital DNE does not exist, right? Existence, what we said about existence, if LHL is equal to RHS. If LHL is equal to RHL, then only the limit will exist. In this case, LHL is 1, RHL is 2. So obviously, the limit will not exist. Simple question. Let's move on. So you can actually make a point here for any greatest integer function. If you are trying to find out, let me repeat. So for a greatest integer function, okay, if you are finding the limit at integer, okay, finding limit at integer will never exist, bacha, will never exist. Why, sir? Because RHL will be the same number. If this integer is I, the RHL will always be I and the LHL will be I minus 1. Okay, in our case, what was this I? This I was 2, right? This I was 2. So I got RHL as 2 and I got LHL as 1. If I take, let's say, limit, same thing I'll take, x, at x equals to 15. What will happen? My RHL will be what, bacha? 15. And my LHL will be what, bacha? 14. Okay, again not equal, so does not exist, again does not exist. Check here. If I check for 15, if I have somewhere, let's say here 15, what will happen at 15? There will be a point over here like this. This will be my point 15. Okay, and over here I'll have a point like this. This will be my value, what? 14. So on the left side I'll get 14 and right I'll get 15. So that's what I written here. Left is 14, right is 15. So always left will be I minus 1. The integer I minus 1 and RHL will be always I, simply I. Okay, so does not exist. Okay, moving on to the next problem. I hope you understood the case of greatest integer function. This is clear? Okay, sir. Now, second problem, trigonometric function, tan inverse of 1 by x, okay, where x is equal to 0, x is equal to 0. So again, let's do this. I'm trying to approach x from negative side, okay. So from the value before this, so I will have what? This is my LHL, this is my LHL, okay, sir. If I do that, what I'm going to get? This will become what, bacha? This whole thing will become negative infinity. Check here. My y will be tan inverse of negative infinity. Please check. Please check. If I'm taking this x as negative of value, some negative value if I take over here, before 0 is negative, right? So this will be negative infinity. 1 by negative value will be negative infinity. 1 by 0 is what? Infinity, no? But it is not 0. It is nothing but 0.0000000, somewhere like this, 1. So it is going to be what? Infinity only. But which side? A minus sign is there, so negative infinity. Correct? Same way, if I take RHL, x tends to 0 from the positive side. Means I try to approach x from this side. Okay? If I do that, what I'm going to get? What I'm going to get? Y equal to tan inverse of plus infinity. How, sir? Same way, 1 upon 0.00000 like this. Okay, this is positive, so it will be what? Positive infinity. Alright, I hope you understood this. Okay, now let's quickly look at the graph of the tan inverse. I only taught you this, so I hope you remember. Don't say no, sir. Don't say in the comments no, sir. Okay, so if I remember the graph, I think this was it. Okay, not perfectly drawn, sir. Let me do it again. So this was the graph, something like this. Okay, for tan inverse, y equal to tan inverse of x. What was this value? Pi by 2. This was what? Minus pi by 2. The range value was, the domain was negative infinity to positive infinity. Correct? Check here. At negative infinity, what is the value of y? Minus pi by 2. What is this going to be? Minus pi by 2. And at positive infinity, confusing, right? So if I have to do it again, let me write it here. So I can simply write LHL from here as minus pi by 2. What about RHL? What about RHL? Tan inverse of plus infinity. So when x is going, this is what? X, right? This is x, no? So when x is going infinity, when x is going infinity, what is the value of y? When x goes to infinity, y is trying to approach pi by 2. Trying to approach pi by 2. So check here. LHL is minus pi by 2. Again, what can I say? LHL is not equal to RHL, sir. So limit will be, limit does not exist. Does not exist when x tends to 0 for this question. Okay, I hope this is clear. Clear, right? Yes, look at the graph. Plus infinity, it is pi by 2. Minus infinity, it is minus pi by 2. They are not equal, means limit does not exist. Moving on to the next question. Okay, about this, limit of greatest integer of sin x. Limit of greatest integer of sin x. How will I do this, sir? Okay, please check. Please check. So I will again do what? Pi by 2. When x tends to pi by 2, from which side? From plus side, let's call this to be RHL. Correct? For RHL, x is trying to move to pi by 2 from right side. What will happen, bacha? Okay, think. Y will be something like this. Please pay attention. Y will be what, bacha? What you have written, sir? What have you written, sir? Please check. What is this, sir? This is the value pi by 2. Okay. If I try to add value pi by 2, what is the sign function? 1. Add pi by 2 sign is 1. But right before pi by 2, means if I am trying to approach pi by 2, right before, what is that value? Will be something less than 1, no? It will be like 0.999999 like this. Okay. If I am trying to approach from left side, from right side, what will be this value? If I am approaching like this, it will be 1. So again, sorry, my mistake, sir. If I am trying to approach the same value pi by 2 from the right hand side, what will happen again? Again it will be some value less than 1. So 0.999, Because the maximum value is 1. The maximum value of this graph, if you look at here, is 1. Before or after, the value is decreasing. Please check. Before, after, the value is less. After also value is less. So I can say even for RHL, even for not RHL, my LHL, I wrote here RHL already. So even for LHL, when x tends to pi by 2, from the left hand side minus, I get y as something less than 1. Because sin x will be less than 1, no? Either you take left of pi by 2 or right of pi by 2. Either you take left of pi by 2 or right of pi by 2. Right before or right after. The value will be always something 0.9999 like this. So it will be less than 1. So what happens if you take GIF less than 1? Please check here. I drew the graph, right? If I take x less than 1, please check. For any value less than what will happen, bacha? It will be 0, no? It will be 0, right? At 1 it is 1. After 1 it is 2. Before 1 it is 0. So I will reach here what? I will reach here as this will be 0. This will be also be 0. Okay. So basically what happens? LHL is equals to RHL. Okay. Hence limit of sin x at x tends to what, bacha? Pi by 2. At x tends to pi by 2 is actually existing and is equal to 0. Because L1 and L2 are 0 and 0. So limit exists. Limit exists and it's equal to 0. They ask us to find the limit value. So this is nothing but 0. I hope this is clear. Okay. Just try to see the graph from here. From left it is again less than 1. From right also less than 1. And greatest integer function. We know that the greatest integer function either for the value less than 1 is always 0. So goes like this. Moving on to the next problem. Alright, sir. What is this question? Limit at x equals to 1. Limit at x equals to 1 for the function. What's the function here, bacha? Y equals to 1 upon this. After looking at this, we can say that there will be some restriction. Why? Means wherever this denominator is 0, the function will not be defined, right? Correct, no? This is a rational function. Whenever this denominator is 0, the function will not be defined. Okay. So let's quickly write the domain in this case. Whenever you have a function like this, no? Means some restriction is there, try to write the domain. Write the domain. Domain if I have to write, check here. I can take any value. So whenever it becomes 0, that's the problem, right? When will this greatest integer function will give you answer as 0? Think. When will this function, greatest integer function, give you answer as 0? When the graph is between 0 and 1. Please check. Means if I take 0.05, 0.005 or what? Even if I take 0, then it will be 0. For 0, 0.005, 0.05 or 0.99999 like this. For all the value between 0 and 1, including 0, obviously, including 0 and open 1. Because at 1, what will happen? At 1, if I put 1 here, this will become 1, no? So I will not have to take 1. I don't have to take 1. Only the value starting from 0, including 0 to value just before 1. So for all this value, the function will not be defined. So how will the domain look like? Minus infinity to 0, both open. Because 0 cannot be defined. 0 if you take, this will become, denominator will become 0. If you take 0 as x, the denominator will become equal to 0. So I cannot take 0, union, starting from 1 to infinity. Please check. If I take 1, it is okay, no? If I take 1, not a problem. At 1, it will be 1 only, so not a problem. This is my domain. This is my domain. I hope this is clear. So let me erase this part. I hope this is clear. Now we have defined the domain. We got the domain of the function given as 1 upon greatest integer of x, sir. Okay, sir. Alright, moving on. So, they are asking at what? At x equals to 1. At x equals to 1. So let's do this. I'll find RHL first. What is RHL? X tends to 1 plus on the right neighborhood of 1. What will happen at right neighborhood of 1? Check the function y. Y will be nothing but 1 upon something 1.00 something. 1. Let's say 1.0000 like this. 1.0000 like this. What will happen to this? 1 upon 1. Correct, na? 1.00 will be 1 only, no? It is not 2. Just right next to 1. Right neighborhood means right next to 1. Very small value. So 1 by 1, nothing but 1. So what is my RHL? At x equals to 1 positive, y is 1. So RHL is 1. What about LHL? What about LHL? X tends to 1 negative. Check here. At 1 negative. At 1 negative, function is not defined. If you move before 1, will be what? 0.999999. This is what the meaning, no? X of 1 negative. 999 like this. Correct? If you try to write this, what will happen to this function? If you put it here, 0.9999999 like this, this will give you 0. This will give you 0. In that case, this will become undefined. So this is not part of the domain. So again, very important part. Write this as note here. Limit is defined in domain only. In domain only. Okay, chaliye. So 0. So it means it will not exist. Correct? This part will not be existing. So it means this is not there. This is not defined. I cannot define the LHL. Not defined. So I don't have to compare over here. So I can simply write the limit of the function, the limit of fx at x tends to 1 equals to 1. Why? Because this is equal to RHL. Because LHL is not defined only, then there is no point of checking LHL and RHL. Okay, it's an undefined number, so you cannot find it out. So fx equals to 1. The answer is the limit exists and equals to 1, sir. Equals to 1, sir. All right, sir. Now, so we have few more questions left. Not much, only few more. Let's complete all those questions and conclude the session. Okay. This is again, as let me recall again. This is nothing but your revision of limits, so that we can start with our calculus unit. And we can continue with our continuity and differentiability from the next session. So let's do this question. Find the value of, okay, this is a good question. 2 power x, 2 power 3 minus x minus 6, and this 2 power minus x in the root, 2 power 1 minus x, okay, in the denominator part. Only this part is in the root. I hope you can see that. Okay. Alright, so, and x tends to 2 is by condition where we have to find it out. So let's check whether it is undefined or not over here. Let's check. If I take 2 power 2, let's check whether it is indeterminate form or not. Just for fun. Let's check. We can find the limit, but let's check. 2 power 2, okay, plus 2 power 3 minus 2, okay, minus 6. Again, root of 2 power minus 2, okay, minus 2 power 1 minus 2. Please check. 2 power 2 is 4. 2 power 3 minus 2 is nothing but 2 minus 6. What is this? Root of 1 upon 2 power 2 minus 1 upon, sorry, one more step, let me write. This will be 2 power minus 1. I'll get this as 6 minus 6. Over here I'll get it as, what is it? 1 by 4, right? So basically 1 by 2, no? The root will be 1 by 2. And this is again 1 minus 1 by 2. What is the answer? 0 by 0. What is this? One of the indeterminate form. Means I cannot find the value here. This is indeterminate. This is indeterminate at x equals to 2. At x equals to 2. So what we're going to do? We're going to find the limiting value. Let's see how we can do that. So I think we can use substitution here. Please check. 2 power x is coming all the time. So even this is there, but in denominator is there, no? I can write 2 power 3 minus x as 2 power 3 upon 2 power x, right? So everywhere I have this notation 2 power x, which is making our life difficult. So 2 power x, I can take it as a number, maybe t I can take t, okay? So what happens? Can I transform this equation? Now check. The limit was given for 2. Remember this. Students make mistake here as well. They will change the function. They will use the substitution here, 2 power x as t, but they will not change the limit. Okay? So if the function was given in the variable x, right? Limit was given in the variable x only. But now you have changed the function to t. How will the function look like? First check that. The function will look like this. So function fx will look like this. 2 power x will look like just simply t. First one. This will look like plus 2 power 3 upon t. Please check. 2 power 3 minus x written as 2 power 3 upon 2 power x. 2 power x is t. Okay. Next what? Minus 6. This is my numerator. What about denominator? This will look like this, bacha. Root of 1 upon t. Correct, na? I wrote it here. 2 power minus 2. 2 power minus 2, basically 1 upon 2 power 2, so 1 upon 2 power x will be, this is nothing but, please check here, this is nothing but 1 upon 2 power x. 2 power x is t, means 1 upon t, 1 upon t, okay? Hope this is clear. What about this? Simply 2 upon 2 power x, so simply t, please check. I can write this as 2 upon 2 power x, so t. Alright sir, let's erase this part, not relevant. So I have to simplify this to get our expected function. Let's check here. So I get here t square plus 8 minus 6t, only numerator I am writing, whole thing divided by t, correct na, because this t will remain in the denominator. Now what happens to the denominator part, this part? I can write this as 1 by root t and this again 1 by 2 by t. What's the LCM? Root t only, sorry, t only, correct? So this will become what? Simply root t and minus 2. Please check, please check. This is nothing but 1 upon root t, and whatever I have over here 2 upon t. What's the LCM of root t and t? T, right? Root t and t, LCM is t. So what we have to multiply over here? We have to multiply with root t only. Multiply with root t only. If I do that, I get numerator as root t, and this will be simply 2. So root t minus 2 upon t. Okay. Let me erase this part. Not relevant. Not required for the steps. Okay, sir. This much you understood, sir. All right. Let's check here, bacha. This t and t will cancel each other. Correct? Because both of them are denominators of both numerator and denominator. What I get final function as? T square minus 6t plus 8 upon root t minus 2. Root t minus 2. This is my new function. Is it in x? No, sir. It is in t. It is in t. So I have to erase it over here and write it as t. Write it as t. Okay, sir. But they are asking us to find limits, no? So let's see here. Limits. So I have write like this. Limit. What was it? T square minus 6t plus 8 upon root t minus 2. Please check. Root t minus 2, correct? Now what was the limit? X tends to 2. If I write here x tends to 2, will it make sense? No, sir, there is no x. There is no x. Then what are you going to do? Check here. Please check here. The most important part of this question. When this was true, when x was equal to 2, right? So when you put x equals to 2, what I'll get? I'll get 2 power 2, right? So this will be what? T. 2 power 2 will be what, bacha? 4, no? 2 power 2 will be 4. So I get t value as 4 now. When x is 2, when x is moving to 2, please check here. When x is going to 2, my t will, since I have taken this as substitution, my t will go to 4, right? My t will go to 4. Please see here. When x tries to move to 2, t will try to move to what? 2 power x, which is nothing but 2 power 2, which is nothing but 4. I hope this is clear. I hope this is clear. Okay. I can write over here only. Chaliye, let's move on. Okay. So I don't have to write this. I have to write in terms of t. So I have to write this as what, bacha? As t. As t equals to 4. Is it done, sir? Can we solve this question directly from here? No. If I put 4 here again, check here. 4 square is 16. 16 into 2 is 12. 16 minus 12 is going to be again what? 4, right? This will be 16, right? And this will be what? 24, right? Plus 8. Again 16 plus 8 is 24. Minus 24 will be 0, sir. This will be 0, sir. What will happen to this? Root of 4 will be 2, sir. So 2 minus 2 will be again 0, sir. So again, sir, it is going to be 0 upon 0 form only. Then, sir, why did we do all the steps? Why did we do all the steps? Because to make our work easier, bacha. It is 0 by 0 form. We have not taken anything out. We have just taken the substitution. We have not eliminated the indeterminate part. We have just taken the substitution. Now we will eliminate it. Let's see how. Can we factorize the numerator? Yes, we can, sir. How will this look like, bacha? T minus 4 and t minus 2. Correct? Numerator will look like this. Please check. T into t is t square. Minus 4 into minus 2 is plus 8. Minus 4 into t is minus 4t. And minus 2 into t is minus 2t. Minus 4t and minus 2t is minus 6t. Please, if you're not sure about it, do the split the middle term for this trinomial and get this expansion. Okay? T into t, t square. Minus 4 into minus 2 is plus 8. And minus 4 into t is minus 4t. And minus 2 into t is minus 2t. Minus 4t minus 2t is minus 6t. Okay, sir. What about this, bacha? This remains same, sir. limit will also be continued like this. Limit t tends to 4. Okay. Can we cancel now? No sir, we cannot cancel. Let's simplify further. Let's simplify further. Please check. I get this as, I can write this as what? Root t square minus 2 square, and this as t minus 2 upon root t minus 2. Please check. I can write this as a square minus b square. Root t square is t, 2 square is 4. What will my next step look like? Please check. This will become limit, again t tends to 4. This will be what, bacha? Root t minus 2 upon root t plus 2. This is the expansion, a minus b, a plus b. And next is what? T minus 2. Next is what? T minus 2. This is as it is. This is as it is upon root t minus 2. Please check here. Please check. Correct. What will this become now? Limit t tends to 4. Limit t tends to 4. Correct. This will be what, bacha, left now? Root t plus 2 into t minus 2. Let's see the substitution, please. Put the 4 here. If I put the 4 here, it will become root of 4 plus 2 times 4 minus 2. How much is that? Root of 4 is 2 plus 2 times 2. How much is that? 4 times of 2. How much is that? 8. How much is that? 8. So my limit value of the given function was the given function limit of fx when x tends to 2, or limit of this modified function with x when t tends to 4 is nothing but 8. Is nothing but 8. I hope this is clear. Okay. Please check the function. This value, the limiting value is coming as what, sir? 8. Coming as 8. Coming as 8. Visible, sir. Okay, sir. Okay, sir. This is visible. Correct. All right. Moving on to the next question. Next question, sir. Okay. All right. So if I put x right now, what will happen? This will become 0. Correct. Let's check right now. If I put x here, this will become 0. Numerator is 0. Denominator will become what? Root 5 minus root 5. Again what? 0 by 0. So indeterminate form exists. How can we solve it? Let's rationalize. Let's rationalize. How? Why, sir? Because you can see the form. A minus b is there. Root is there. If I make it square, the root will cancel out. Then something might come out of it. So we have to rationalize it. Let's see how will that look like. So if I rationalize it, this will become, please check, x upon. So look, if you remember the chapter, the way to take out the indeterminate form was one of this, right? Rationalization was there, some substitution was there. So one of this, the previous one was on substitution, this was on rationalization. So I hope you remember this. That's why I'm doing this chapter, right? That's the point of doing revision. So this will look like what, bacha? Root 5 minus x plus root 5 plus x. Correct? Divided by same thing. Root 5 minus x, whole thing in the root, plus root 5 plus x. I hope this is visible. Yes, sir, visible. Okay, how will this look like? X times of root 5 minus x plus root 5 plus x. What about denominator? Sir, a minus b. Please check here. This is nothing but a minus b and a plus b. Correct? A minus b, a plus b. How will this look like? A square minus b square. How will this look like? A square minus b square. So, root 5 minus x the square. Correct? Not visible. I'll add a little bigger. Let me write a little bigger. Okay. Visible नहीं है sir. Root 5 minus x square. Okay. Minus root 5 plus x square. Root 5 plus x square. So what I get here? Please simplify. Numerator will remain same. X times of root 5 minus x, okay, plus root 5 plus x, okay. What about this? What about this? This is simply 5 minus x minus 5 plus x. Correct, sir? Correct, sir? Please check here. Please check here, bacha. So if I do that, what I get? If I do that, what I get? Next step, please check. I get x times of root 5 minus x plus root 5 plus x, okay, divided by 5 minus x minus 5 minus x. Yes, no? This is correct, right? 5 minus x minus 5 minus x. What happens? 5 and 5 goes out. 5 and 5 goes out. What I have left? I have left as minus 2x. Now can you see from here? I think you can see from here. This is going to be x times of 5 minus x plus divided by minus 2x. Okay, please check. Goes out, right? Goes out. Okay, now I will use it in the limit. So what is the function now transformed into? This thing, the function fx. If this is my function fx, I have transformed it into this part. Please check. Now I have this as limit root 5 minus x minus root 5 plus x. I think this is plus. Let's check. This plus sign. Minus 2 is left in the denominator, nothing but. And limit is acting at x equals to 0. Do I have to change the limit, sir? No, I have not changed any variable. So why will I change the limit? Now just simply put the x value in the wherever the x is present in the function. So I get this value as root 5 minus 0 plus root 5 plus 0 divided by minus 2. How much is this going to be? Root 5 plus root 5 upon minus 2. How much is this? Plus 2 root 5 upon minus 2. 2 goes out. My answer is what, bacha? Minus root 5. My answer is what, bacha? Minus root 5. What is then? Limit of fx, the function that was given at x equals to 0, at x tends to 0, forgive me, is equal to minus root 5. This is my final answer. Please check. X tends to 0, the limit value is minus root 5. Limit value is minus root 5. I hope you are able to understand this. Okay, I hope this is being helpful, because this session is about helping you so that you are able to understand the next coming sessions. All right, so I hope this is helping, bacha. Correct, sir? Yes, sir. Okay, quickly we will conclude the session. Let's conclude the session, sir. Okay, this is your PYQ from KCET. Okay, has been asked in 2022. 2022 they have asked this question. This is a very simple question, right? I can do the rationalization over here, no? Let's do the rationalization. Why, sir? Why, sir? Because if you do the rationalization, bacha, y cube will get cancelled. Can you not see that? 3 plus y cube will become, in the root is there, it will become whole square. So I will get this as free of whole square. So 3 plus y cube, this will simply become 3. So 3 and 3 will cancel each other, no? Sir, you are saying too many things. Let's solve it, no, sir. Let's solve it, sir. Okay. If you want to check the indeterminate form, put here y is 0, denominator is 0. Over here, this will become root 3. This will become minus root 3. So again, this will be 0. So what is the form here? 0 by 0. 0 by 0 form is there. Okay, sir. We have to take it out. How will we do that, sir? So let's take the function y is equal to what, bacha? Okay, not y, because the function is given in the variable y. So we'll not take the variable y. We'll simply take it as f of y. F of y. What is this given as? Please check. 3 plus y cube minus root 3 upon y cube. Now what I'm saying is, asking you to rationalize the numerator. If I do that, how will this look like? Please check. How will this look like? How will this look like? So I will have this as f of y is equal to root 3 plus y cube minus root 3 multiplied with the factor, the rationalizing factor, 3 plus y cube minus, plus root 3. This is the numerator. What about denominator, sir? You will have it as y cube multiplied with this part, 3 plus y cube in the root plus root 3. Please check. This is my RF, no? Rationalizing factor. This is my rationalizing factor. So both is multiplied on numerator and denominator. So a minus b, a plus b. A, please check here. This is a minus b and this is a plus b. A plus b will become a square minus b square. It will become a square minus b square. So square of this. Square of what? 3 plus y cube the whole square minus root 3 the whole square. Okay, divided by, we'll write the same thing. So y cube times 3 plus y cube plus root 3. 3 plus y cube plus root 3. This is nothing but your f of y. Your f of y. Please check how will this simplify. I'll get this as square and root will cancel the effect. Square and root will cancel the effect. So I'll get the numerator as 3 plus y cube from the first term. Next I'll get it as simply 3, because again square and root will cancel the effect, divided by, same thing I have to write here, y cube (3 plus y cube plus root 3). Now check here, 3 and 3 cancels each other. That's what we're talking about, no? 3 and 3 will cancel each other. What I've left here? Y cube. Please check on the next slide. So my f of y will look like this, bacha. Y cube upon y cube into 3 plus y cube plus root 3. Am I right? Please check. 3 plus y cube plus root 3, correct? After cancelling 3 and 3, only y cube is left in the numerator. So this and this is gone. Now what is left now? Simply 1 upon 3 plus y cube plus root 3. 3 plus y cube plus root 3. Okay, sir. Now what is the question they are asking? Limit f of y when y tends to what? 0. Y tends to 0. Y tends to 0. If I do that here, I'll get 1 upon root 3 plus 0 plus root 3. Answer is what? 1 upon root 3 plus root 3. Correct? What is this? 1 upon 2 root 3. 1 upon 2 root 3. I hope you can see that. 1 upon 2 root 3. Please check your answer. 1 upon 2 root 3. Any option is there? Option A, sir. Option A is correct answer. Option A is correct answer, sir. Option A is correct answer. 1 upon 2 root 3. I hope you can see this. This is visible, right? Let's move on. Okay. Last question of the day, I think. Again, this is the PYQ. So you can see the PYQ is also of the same kind. Okay. So when we do the limit chapter, we will see these questions in detail. But right now, just let's recollect it and we can just make a comment that even the PYQs are of the same kind. Not that difficult. Okay. Sin 2 plus x minus sin 2 minus x. Alright. Sin 2 plus x minus sin 2 minus x upon x. If I put 0 right now, this will be 0. This will be sin 2. This will be sin 2. See, 2 plus 0 is sin 2, no? 2 minus 0 will be again sin 2. This will be 0. This will be 0. So what is the form? 0 by 0. Indeterminate form is 0 by 0. So they are saying that if you find the limit at x equals to 0, they are saying it exists. They are not asking you to check whether it exists or not. They are saying it exists and is equal to a cos b. Say that it's equal to a cos b. They are asking you to find the value of a and b. They are asking you to find the value of a and b, sir. So quickly find the value of a and b. Alright, sir. Let's do it. So let's take the function first. So my function is nothing but y equals to sin 2 plus x. Now I will need you to remember the formula of sin c minus sin d. Correct? Correct, sir? Yes. Sin c minus sin d is what, sir? Sin c minus sin d. It is 2 times of sin c minus d upon 2 times of cos c plus d upon 2. Correct? Sin c minus d upon 2 into cos c plus d upon 2. Am I right? Let's check. Let's apply. We'll find it out. So if I do that, my c is 2 plus x. My d is 2 minus x. C plus x. So 2 plus x is my c. Please check here. C is 2 plus x. Compare, please. C is, forgive me, this c here is 2 plus x. And this d here is 2 minus x. 2 minus x, correct? If I do c minus d, if I do c minus d by 2, how will this look like? Sine of, not sine, 2 sine, right? It will be 2 sine. I'll write like this, 2 plus x minus 2 minus x, whole thing divided by 2. Correct? Now times cos of the sum of these. So 2 plus x plus 2 minus x, whole thing divided by 2. Please check. C plus d. So 2 plus x is c, 2 minus x is d. So 2 plus x minus, so plus 2 minus x. So like this, divided, whole thing divided by x. X is there in the denominator. Okay. Let me simplify it over here only. So if you do that, x and x will go out. x and x will go out, plus x minus x will go out, right sir? Not visible sir, after cancelling it is not visible sir. Okay, let me remove that part and write it here, next step. So I can write this as 2 sine 2 plus x minus 2 plus x by 2 times cos, this will be simply 4 by 2, whole thing divided by x, whole thing divided by x is visible, right? This 2 is not visible sir, this 2 is not visible bacha, this 2 is there, there's a 2 there, correct? So if you check here, I will get y value as, I'll write it in the next slide, y value will be equal to 2 sine, please check, 2 plus x minus 2, so I can write, cancel this 2 and 2, cancel this 2 and 2, so I'll have only x plus x, which will be what bacha, 2x by 2, please check, 2x and divided by 2 is there. Now what is the next one? Cos 4 by 2, nothing but simply cos 2 divided by x. Okay, so cancel this 2 and 2. What is the final answer? 2 sine x cos 2. Now we know there's a form in trigonometry like this, so I can write x only for sine x. I'm writing x into division but only for sine x. Now this is my function y. What is they're asking? They're asking you to find limit y when x tends to what bacha? 0. Check here, x tends to 0. Okay, so if you do that, what you're going to be, you'll get 2, cos 2 is a constant, so keep a cos 2 outside, and this will become limit sine x upon x, where x tends to 0. We know this is nothing but 1. This is nothing but 1. So my answer will be 2 cos 2 times 1, which is nothing but 1. Okay, so what is this given equal to? This in the question they have given equal to a cos b. A cos b. So right here, a cos b. Please compare a is 2 and compare b. B is 2. A is 2, b is 2. Please check the answer. Option B. Option B. A is 2 and b is 2. I hope this is clear, bacha. I hope this is clear. So what we have done today, is we have revised limits a little bit. Okay. We learnt about the concepts, whatever is there in this chapter. I hope everything is visible on the screen. Right? Okay. So we have learnt the concepts. Why do we need limits? Okay. What's the meaning of function not defined at a point? What's the meaning of limit not defined at a point? What do we mean where the limit will exist or not? Then we will see the applications of limits in our coming chapter. Okay, which is continuity and differentiability. Continuity and differentiability. Okay. I hope this session was interesting and you learned few things today. Okay. So keep working hard. Keep solving all the questions, right? So I hope your energy level is not getting down. Make sure that you maintain the energy level, especially in the most important unit of your PU2 syllabus. This will help in boards and your KCET. So the calculus is coming, right? So maintain the energy, be motivated, okay? And keep working hard, be with me, okay? If you have any doubt, any query, comment in the video, okay? Comment in the sessions that, sir, this is my query. This is what I want to ask from you. I will try to answer all the questions, okay? So that's it for today. Keep working hard and take care. Bye-bye.